at this point. And they will do various things to the receptors on the postsynaptic membrane. So some of them, for example, go and block those receptors and prevent the neurotransmitter from combining with the receptor and opening the channels. Okay, some of them go and block the receptors and make the channels open and then don't break away because the enzyme can't break them down because it's the wrong shape for the enzyme to break them down. Then the channel just stays open. Okay, so for many of your kind of recreational drugs, the ones you know are out there on the street but you don't do, that's how they work. Yes, Mrs. Page?
What effect does it have? Like on the
Mouse
blocking
party.
stuff.
Mouse party.
Do you like your mouse party?
I do. Okay, so what this is going to do is it's going to show you various different drugs and how they actually work. Okay, all right, so Tony. What?
He looks so chill.
Because they're on drugs, Tony. Okay. Yes, of course I can. Okay, right. Yeah, Isabella, which mouse?
That mouse is dancing in the back.
This one.
Yeah. Oh, so cool. James, you mustn't dance. This is not a fun time. You have to experiment on. No. Hey, I feel bad.
Shh, watch it. So it's on ecstasy.
Serotonin transporters are responsible for removing serotonin molecules from the synaptic cleft after they have done their job.
Whoa. Okay.
Ecstasy mimics serotonin and is taken up by serotonin transporters. In fact, ecstasy is more readily taken up than serotonin itself.
No. So I see the green.
This interaction with ecstasy alters the transporter. The transporter becomes temporarily confused and starts to do its job in reverse. The transporter starts transporting serotonin out of the cell. The excess serotonin becomes trapped in the synaptic cleft. As a result, it binds again and again to the receptors, overstimulating the cell.
Okay, does that make sense?
Ecstasy affects serotonin pathways responsible for mood, sleep, perception, and appetite. Ecstasy also indirectly interacts with the reward pathway. The excess serotonin stimulates a milder release of dopamine along the reward pathway, giving ecstasy slightly addictive properties.
You're so dancing! You're fine. The white one in the middle. Yeah. You just killed it.
Oh, doctor.
MC is resisting it. You have to put him in.
Ah.
You knocked the other one out, He doesn't want to get in. No, really. You don't want to touch.
Okay, so this is methamphetamine.
I thought it was on cocaine.
I don't think so, is it? Methamphetamine?
Mate.
No.
Oh, first one.
Dopamine transporters are responsible for removing dopamine from the synaptic cleft. Because meth mimics dopamine, it is taken into the cell by the dopamine transporters.
So meth is a fun
Once inside the cell, meth enters the dopamine vesicles, forcing the dopamine molecules out. The excess dopamine in the cell causes the transporters to start working in reverse, actively pumping pumping dopamine out of the cell and into the synapse. The excess dopamine becomes trapped in the synaptic cleft. As a result, it binds again and again to the receptors, overstimulating the cell. Meth is highly addictive because it works directly on the brain's reward pathway, making the user feel intense pleasure and exhilaration.
Sydney,
Yeah.
which mouse?
I can't really see. The one on the couch. Yeah. He's chilling. He experiments.
Isabella, you've already had two.
No, I want the one on the couch. Yeah.
Keep going, drunk mouse.
Before heroin enters the system, inhibitory neurotransmitters are active in the synapse. These neurotransmitters inhibit dopamine from being released. When the body's natural opiates activate opiate receptors, the release of inhibitory neurotransmitters is shut down. Without inhibition, dopamine can be released. Heroin mimics natural opiates and binds to opiate receptors, turning off dopamine inhibition. Dopamine is allowed to flood the synapse, producing immediate feelings of sedation and well-being.
That's what we need.
Yeah. This one mimics you being happy.
Right. This little one, LSD.
LSD.
Do you guys do LSD anymore?
Yeah. I did it as a kid. LSD tough. Take your time. You trip.
LSD acts almost exclusively on serotonin neurons. LSD chemically resembles serotonin and elicits its effect by binding to serotonin receptors. There are several types of serotonin receptors in the brain. Each is responsible for performing specific functions. LSD interacts with particular receptors, but not always in the same way. Sometimes LSD may inhibit them, and sometimes it may excite them. This is one reason why LSD has complex sensory effects. LSD and other hallucinogens excite a particular region of the brain known as the locus coeruleus, or LC. A single neuron from the LC may branch into many different sensory areas of the brain. The LC is responsible for feelings of wakefulness and evoking a startled response to unexpected stimulus.
I need that right now.
That makes
You
you
need
trip.
that problem.
Okay, what haven't we done? We've done ecstasy, we've done that one. What was that one?
Cocaine.
Ecstasy.
Marijuana.
Ah,
I'm so dead.
oh. You do know I'm now going to go through 100% of the circle of death.
So, my little drunk mouse. For people on antidepressants, do the antidepressants, it's for people with low serotonin. No, it's a pretty simple question.
No, I know that.
But
And my answer is I actually don't know.
I was just going to ask if
Yeah.
if the like receptor things send off more serotonin because of it. Like if the drug
And I
makes
have
them
no
send
idea.
off more
I don't know. I don't know whether the drugs mimic serotonin and act in their place, or whether they stimulate more release of serotonin. I absolutely don't know.
So Dan,
Yes.
with serotonin, is there dopamine? Because I'm a little mixed up on the chemicals.
Oh, there are a whole lot of different neurotransmitters, some of which are stimulatory and some of which are inhibitory. So some of them would make an individual more happy and excited, and some of them actually slow down the effects of neurons. So it depends on what neuron you're looking at and what neurotransmitter is released from the presynaptic.
So when you're referring to like dopamine and serotonin and all
That
of that.
makes you happy and
Yeah.
Yes.
So then
Well,
that-
serotonin
that's the
certainly does.
neurotrans-
Does dopamine as well?
Dopamine
I
is
think
like
so.
when you feel like important or like love or something. Like when you get a message on your phone, you're like, ah, it's like dopamine.
Please would people send this child messages? She's unloved.
Yeah, guys, I'm so lonely.
Yes, ma'am. Those are types of neurotransmitters.
Circle of death!
Oh my goodness.
James, you know what chemical it is that makes you like sad? Is it a different chemical?
It's
When
teaching.
you don't have enough serotonin. The lean cheeks.
Teaching.
And now it's just got more. Pardon?
So it is a type of neurotransmitter.
What, love?
Dopamine and serotonin.
Yes.
So
And acetylcholine is also one.
do we need to know them, ma'am? Or can we just say neurotransmitters?
You can just say neurotransmitter.
They were like dopamine, serotonin, I was like, wow, I might have missed something here.
No. So they're various different ones.
That was a fun game.
It was while it lasted.
Inject mouse, not eject mouse. I thought we were gonna like stick him with a needle or something. I thought
Then
I
lock it up.
was so confused. Yeah, I thought we were gonna do something with drugs. I thought I said eject, I thought I said inject. Sometimes
Yes.
really good. Thank you. It's these little. Did you ever watch that? One was taste the smile. Oh, yes, now I do. That was the one. It was the brain, wasn't it? I don't remember. Yeah, something like that.
What it was?
And it was taste the smile. Taste the smile and touch. Yes. No, I remember. I like the little. No. Oh, yeah.
What are you doing? Okay, it's now not even doing secret death. It's just completely.
It's not about duty. I mean, it's not with duty.
Okay, all right. You can spend this quality time learning the work that you were whining about, or doing the activities while I wait for this thing to wake up again. If ever. I know why you're not allowed face shields. It's an effort to shut you up. It's not very effective, but somebody hopeful said, let's give Isabella a face shield.
I literally can't breathe though. Like, it's so hard to breathe.
I know. I'm telling you, we're going to breed a whole generation of mouth breathers.
And like, my nose always runs with these masks.
Yes.
It's
Always runs.
I'm listening.
Can you look at activity 6.6? Can you look at activity 6.6? In question 1, it says describe the difference between myelinated and umylated fibers.
Unmyelinated.
Yes. Does it mean like the physical difference or in the graph?
Question 1.
Yeah.
No, it's physical difference.
Okay.
Because if it's asking the graph, it would be asking the speed of conduction in
Oh.
myelinated and unmyelinated. I'm listening.
Here it says the receptors, internal receptors respond to pressure, stretching, or changes in the pH. So I know that with the, I can't remember what it's called now, but when the pH is too low, then they send hydrogen in, and then when the pH is too high, then they take it out. But then if it's, how does the stretching work? Like how does the receptors, how do they identify the stretching?
They're tiny little receptors called proprioceptors that are in muscles and joints, where if I say to you now, what position is your right foot in? Can you tell me what position it's in? I beg your pardon? Yes, okay. So without looking,
Yeah.
those proprioceptors sense changes in pressure and movement and
Yeah.
whatever. So they constantly send impulses to the brain going from all the different parts of the body. This is the position that the various parts of your body are in at the moment, and it helps you with balance.
And that's constantly being sent. Without even having to stimulate. It's just
Yes.
because you know where everything is.
They are being stimulated. They're being stimulated by the fact that there's pressure being applied on them, or they're being pulled, or whatever. Yeah. So they're receptors that you don't normally think about when you talk about your different senses. You don't normally think about that as being a sense, but it's a very, very important sense.
So then if you don't have coordination, does it mean that you have like less sharp nervous impulses towards, you just don't have coordination?
No. So one of the things about coordination is sorry. Just let me quickly finish saying, print this, otherwise I'm never going to get it right. One of the things about coordination is that there've got to be certain connections made in the brain. So when a child is born, there's certain connections that aren't even made in the brain that are made in response to what happens. So, for example, I never crawled. I pulled myself along with my bum. I never crawled. And as a result of that. So it's to do with, apparently there's something to do with when you crawl, that movement makes certain connections happen in the brain.
Yeah.
And so because I never did that movement, I don't have those connections. And so I'm uncoordinated. If you make me do a star jump, or if you make me march, I can't do it. I've got to go, I know that I need to move this arm and this leg. So it's not an instinctive thing. I've got to think about it, and then I've got to go, okay, and then I can start doing it. But star jumps as well, I can't do them. There are a whole lot of things that I can't do because I never crawled. And that's why, so there was a time when kids were given walking rings, where they were put into little walking rings, and the walking rings have got, and jolly jumpers that hang from doorways, and they jumped up and down. And people thought they were absolutely great, but what happened is that the kids never crawled. And it raised a whole generation of kids who never made those connections in their brains. But
lying around
no, because yes, because they didn't go through the crawling phase, because in the walking ring, your body's being supported upright. And
So did you have
I put myself on. I was there. So they smack my bum and because nobody reflects to Isabella so that she feels loved.